In Chapter 5, we're going to start reviewing our exponential functions and the inverse of exponential functions, which are logarithms. So we're going to just review everything that we learned from Algebra 2, kind of expand on that. So the first thing that we have here is just making sure that we can get our calculator to behave. I hope that you have a calculator handy, but if you plug this into your calculator, you're just going to do 8 to the negative square root of 2. Your calculator can handle this, so please plug it in and make sure you get 0.053. Okay. We can raise exponents to strange things like 3 to the pi. When you do that, you should get 31.544. And we can also do 2 to the 2/3. Okay. Use that fraction button to do that, and you should get 1.587. So just plug those into your calculator. Make sure that you can get something like that. Now, we want to graph our exponential functions. So exponential functions are when your x, your variable, is in the exponent. So we'll start with this one, y equals 3 to the x. I'm going to create a table of values, and I'm going to plug in what we normally do, -2, -1, 0, 1, 2. So remember, when we do 3 to the -2, the way we get rid of negative exponents is we drop it to the denominator. So that's 1 over 3 squared, which is going to be 1/9. So -2, 1/9. 3 to the -1 is going to be 1 over 3 to the first, which is 1/3. 3 to the 0, remember anything to the 0 power is just 1. 3 to the first is 3. And 3 squared is 9. That does not fit on my graph. But you can see that's what this is going to look like. Now we're going to do the same thing with 9 to the x. I'm not going to show quite as much work, just go a little faster, but I'm going to plug in the same values. So 9 to the -2 is going to be 1 over 81. 9 to the -1 is 1/9. 9 to the 0 is 1. 9 to the first is 9, and 9 to the second is 81. So for this one, this is going to be very challenging to graph. They both go through that point, but this one goes up a lot faster. So it looks like that. And something that you'll notice with your exponential functions is they always have that sort of shape. Okay, they have a horizontal asymptote at 0. They always go through this point. You can see right here, 0, 1. And they're all going to have that in common. Just the higher the base, the faster it goes up. All right, so let's take a look at what happens when we have 3 to the -x instead. So I'm going to graph this first, 3 to the -x. I'm just going to create a little table of values. I'm going to plug in the same points. So we're doing 3 to the -2, which of course is just 3 squared. We're going to do 3 to the -1, which is just 3 to the first. 3 to the -0, which is just 3 to the 0. And then 3 to the -1, which is 1/3. And 3 to the -2, which is going to be 1/9. So when we graph this, I can't fit that one on there. -1/3 I can fit. And it looks something like this. So you'll see that graph is just a reflection of the one that we had in the last question. The same thing is going to happen with 9 to the -x. If we plug in those same points, 9 to the -2 will be 81. 9 to the -1 is just 9 to the first. 9 to the -0 is 1. 9 to the -1 is 1/9. And 9 to the -2 is 1 over 81. So this also will look really similar, just reflected. So I'm sorry, I can't draw anything straighter than that. All right, in the next video, we will talk about the one-to-one property.